So we are still working on derivatives. We're going to look at derivatives of composite functions. So let's make sure we understand what composite functions are. Okay, so we have, so it says in algebra, you did it in algebra, you did it again in pre-cal, look at it again today. So if you have two functions, f and g, okay, you can write f of g of x, right? And that would mean we take g of x and we substitute it into f of x, right? Remember doing that? Or if you find f of 3, you put 3 in everywhere you see an x, right? So if I have f of x equals x to the 7th, g of x equals 3x squared plus 5, then f of g of x means we take this, we put it in here where we see an x. Since we're putting in more than one term, we put it in parentheses, and this is what f of g of x would equal. Make sense? Because we got to make sure that we understand how that works, because we're going to go backwards to pull some things out, and so you got to make sure you can recognize them. All right, so then if we have sine x for f of x, g of x is x cubed, and I want f of g of x, I put x cubed in everywhere I see an x, so I get sine of x cubed. It's not sine cubed of x, right? We're not going the other way. And then here it is going the other way. Cosine of x is g of x, x cubed is f of x, so when we put this in here, then we get cosine x cubed, which we rewrite as cosine cubed x. Okay? Right, because remember that these two things right here mean the same thing. We're going to take some that look like this at some point when we're doing these, and we're going to rewrite them like this so that it makes more sense for our process. So like this is the proper way to write it, but this is the same thing, so sometimes it's good to see the difference. So we need to make sure that we understand the difference between plane functions and composite functions. I have 5x to the 7th. Notice that the x is just x. Here, what I'm taking to the 7th, I could have x to the 7th, but that 3x squared plus 5 got put in there. Does that make sense? That's what makes it a composite function. You have a function inside of another function. Sine x is just sine x. Sine of 4x, 4x is a function inside of sine of x. Cosine x is just a plain old function. Cosine cubed x, because we could rewrite it like this, is a function inside of a cubed function. Okay, so you see the differences there with plane functions and composite functions. All right, so let's say that we wanted to find the derivative of these. With the rules that you have right now, you don't know what to do with this. You would have to take this and multiply it out, right? 3x squared plus 5 times 3x squared plus 5. Then we could use our power rule, right? No big deal. This would make it a little bit worse. Do you want to have to multiply this whole thing out? No. Okay, so that's why we have the chain rule. Right, and that's what it's called. That's what we're going to look at here today about the chain rule. It says in calculus, we need to find the derivative of a composition of functions. We use the chain rule. So notice we have f of g of x here, f of g of x. I'm going to take the derivative with respect to x of this function right here, and I'm going to work from, take care of the outside first. That's why you have this Tootsie Pop, so you can start eating it right now if you want. What's inside the middle of that Tootsie Pop? Or you can wait if you don't want. Chocolate, like a Tootsie Roll, right? What do you have to get through to get to the Tootsie Roll part? The hardness, right? You got to get through that hard candy shell before you get to the Tootsie Roll, right? Make sense? You work from the outside in. You can't choose to start with the Tootsie part, right? Because even if you don't want to eat that part, you'd have to break it to get to it. Does that make sense to you? Y'all with me? You two focus on your Tootsie Pops. Right? I know. How many licks does it take, right? So you have to get through that hard candy shell to get to the Tootsie Pop, or the Tootsie Roll part. Make sense? You have to do the outside of these first. The outside comes first. This is like the F part is like the candy part, the candy shell. The G of x is like the Tootsie Roll part that's on the inside, right? So it's a composite of two different things that we've put together. So we take this derivative, we take the derivative of the outside of the candy shell part, right? So it's f prime of g of x. And while you are taking care of that hard candy shell, that g of x is still sitting in there, right? You haven't taken that Tootsie Roll part out yet. It's still on the inside of there. Then once you're done with the hard candy shell part of it, then you get to take the derivative of the inside. So the derivative of the outside, you leave that thing inside of there, and then you take the derivative of whatever's inside. Okay, make sense? Outside, leave the inside alone, then you do the inside. It's very important that you understand that process because we're going to have so many rules that sometimes you can get them mixed up, and we don't want to get them mixed up. Okay, so another way to look at this, notice that this is f of u, and we're going to use u a lot, use some u substitution at some point eventually. That u just took the place of g of x. So another way to write this is f prime of u times du dx. Okay. So this is the derivative of the function with that thing inside of it. And then this is just the derivative of the inside part. That's all that means. Okay, so it says we use the variable u to represent a function different than x inside the function itself. Du dx is simply the derivative of the inner function. So we're going to find the derivative of f here two different ways. We're going to find it pretending like we don't know the chain rule, and then we're going to do it using the chain rule. So without the chain rule, if I want to find the derivative of this, I'm going to have to multiply it out. So I'm just going to rewrite f of x is equal to, then I have 3x squared plus 5 times 3x squared plus 5. Okay, that's what that squared means, right? So then we're going to multiply it out. I'm still just on f of x. 3x squared times 3x squared, 9x to the 4th. Outside 2 will give me 15x squared. Inside 2 gives me 15x squared, so that's plus 30x squared. And then 5 times 5 is 25. Okay, so that's still just f of x, right? Haven't found a derivative yet. So now I want to find the derivative, f prime of x. Power rule means this first term becomes what? 36x cubed, right? Plus what? 60x. Okay. So not that big of a deal to multiply that out and then use the chain rule. Nothing wrong with doing it that way. But again, if I have this one, do we want to multiply all that out? No, it would be insane, right? So now let's look at what the chain rule says. The chain rule says we take the derivative, or let me just rewrite it again. So f of x, I'm going to rewrite as it is. It's 3x squared plus 5 squared. So the parentheses with the square is your candy shell. The 3x squared plus 5 is the Tootsie part inside of it. So when I want to find the derivative, I take the derivative of the outside, I leave the inside alone. So this 2 gets multiplied out front, so I get 2 parentheses. Inside is the same, 3x squared plus 5. And then 2 minus 1 is 1, so I don't need anything there, right? So I've done this part right here. I've done f prime, g stayed the same, it just hung out in there. Now I need to multiply this by the derivative of the inside. What's the derivative of the inside? 6x. So in the end then, my f prime of x is equal to 12x times 3x squared plus 5, which is the same as 36x cubed plus 60x, and that's the exact same thing we got over here. Okay, so we get the same thing either way. What questions do you have? Okay, so let's try this next one. F of x, I don't need to rewrite it. I do f prime of x. I'm going to take the derivative of the outside function first. 7 gets multiplied out here. 7 times 3x squared plus 5 to what power? The 6th power. Am I done? No. I now have to take the derivative of the inside part, and that gives me 6x. So that means that f prime of x is equal to 42x times 3x squared plus 5 to the 6th power. Once I got to this step over here, I distributed that 12x in there. Can I distribute that 42x right now? No, I cannot, because this exponent isn't 1, right? And we're definitely not going to multiply it out. If I'm solving for it, I could take the 6-3, but I'm not trying to solve, so I don't want to undo anything. This, oh yeah, this would be a safe stop. This would probably be a multiple choice stop also. We wouldn't need to multiply that. There'd be no need to do that. Okay. This right here actually is your safe stop. And then this would be maybe probably more of a multiple choice answer. Okay. Everybody good so far? All right. So now let's look at this next one. I probably need to rewrite that square root, right? What would I rewrite that square root as? 1/2. Okay, so y equals 3x minus 4 to the 1/2 power. So that's still y. It's not the derivative. Okay. And remember, we're not going to use y prime, even though it's not wrong. We're just not going to see it that way. The more proper way to do it is to say we have dy dx. And then we're going to use the chain rule, starting with the power rule. Do the outside part first. I get 1/2 times whatever's in here to the negative 1/2 power. So that took care of the outside. Now I take the derivative of the inside, which is what? 3. Okay, so I'm going to rewrite that as 3/2 times, times 3x minus 4 to the negative 1/2 power. Now we can't leave negative exponents, so I cleaned it up before I worried about the negative exponents, because this is a good way for you to go about this so you don't put the wrong things in the wrong places. I'm going to have a fraction. The only thing that's going to go in the numerator is this 3. So the 3 goes up here, that 2 goes down here, and then I have the square root of 3x minus 4. And then that is my derivative. Okay. What questions do you have? You understand where everything's coming from? It's okay that the square root's in the bottom. Yes. So this whole you have to rationalize the denominator thing, that's kind of up to calculus. And then because we're allowed to leave a lot of other things, we're going to have square roots in the denominator, and it is okay. There will be times where maybe rationalizing would be helpful depending on what we're doing, but we definitely don't have to worry about that. That's a good question. Anything else? All right. Let's go through a few more examples. We're going to find the derivative. Do not leave negative exponents or complex fractions in your answer. Complex fraction is a fraction and a fraction. Okay. All right. So why don't you give this one a try? Think about your Tootsie Pop and give that one a try. Just do the first step, get to the safe stop, and then we'll talk about the rest. I mean, you can keep going if you want. I want you to at least get there. Okay, so I do the outside first, right? So I'll get 5 parentheses 4x cubed plus 3x minus 2. So in that first step, you do not touch the inside. That's step 1, candy shell. Then derivative of the Tootsie Roll gives me 12x squared plus 3. Okay. This is a safe stop, but I can go on to say f prime of x equals, and this would give me 60x squared plus 15 times 4x cubed plus 3x minus 2 to the 4th power. Now, do we have the skills necessary to take that to the 4th power? We do. Do we want to do that? No, we don't. Would this mean that I just get to take each one of these to the 4th power? No, it would be a whole lot of stuff that we don't need to do. We're done. That's it. I did 5 times. I distributed my 5 in here. I can distribute it in here because my exponent's 1. Okay, I saw some weird looks. I'm assuming that's where that was coming from. Any questions about where anything else came from? Make sure you ask me if you're not sure. Okay. On B, do you think we might need to rewrite something first? Yes. Okay, so we're going to do t to the fourth plus 2 to what power? The 2/3, because it's already to the second power, and then this would be to the 1/3 power, so it's to the 2/3 power. So then we do the chain rule. 2/3 comes out front, times the inside remains exactly the same. Then I have to do 2/3 minus 1. What's that? Negative 1/3. Very good. Am I finished? No, I have to multiply by the derivative of the inside, which is going to be 4t cubed. Right? So when I multiply this 2/3 times the 4t cubed, that would give me 8t cubed over 3 times t to the fourth plus 2 to the negative 1/3 power. So then I can say dy dt. Notice it's a dy dt, not dy dx, because we're using a t instead of an x. This is equal to, I'm going to have a fraction. What goes in the numerator? 8t cubed. And in the denominator, I get a 3 times the cube root of t to the fourth plus 2. Okay. What questions do you have? You understand the process here? Okay. Now let's look at C. Do you think I need to do the quotient rule on C? Can I do the quotient rule on C? Yes. Do I have to? No. Okay. I can change this to where I don't have to do the quotient rule, and it will probably make it a little easier. So I'm going to rewrite this as negative 7 times 2x minus 3 to what power? Negative 2. Okay. So you do the chain rule here, at least through the first step. If you want to finish it up, you can. Let's see how far we can get here. See if you agree with me up to this point. Why is it positive? Because it's negative 2 times negative 7. Okay. And then I just multiplied my 2 times my 14 to give me that 28. And then dy dx will be a fraction. Numerator is 28. Denominator is 2x minus 3 cubed. What questions you got? Not that bad? Not that bad. All right, then you do D. Let's see what happens with D. The derivative of the inside, are you sure that's it? Are you missing something? Yeah. Okay. See if you agree with me. If not, ask me a question. Everybody understand where everything came from and why? Yes? Okie dokie. That was the back of that, right? Okay, so I have another sheet of paper for you. More work, yay! All right, so more chain rule. We're going to use some trig stuff and natural logs and e's. So two more transcendental functions that we study are e to the x and the natural log of x. We've already talked about the derivative of e to the x. What is it? E to the x. It's like the easiest derivative you'll have. The derivative of e to the x is e to the x. The derivative of the natural log of x is not the natural log of x. It has nothing to do with the natural log or e, interestingly enough. It is 1 over x. We'll look at y later. Take my word for it right now. Okay, so let's think about this. We're going to kind of write some stuff out in words here. If I want the derivative of the natural log of something, literally write out something. Okay, so the derivative of the natural log of something, no, because this is where things get confused. Because that's basically what I have here. I have the x, and I have this, and we can talk about chain rule, but trust me, this is how you want to think about it. This is going to be equal to 1 over something times the derivative of something, whatever it is. Okay? So the natural log of x is equal to is 1 over the x times the derivative of x, which is just 1. But when you apply the chain rule, weird things, y'all tend to do weird things with this. So what we want to think about it is the natural log goes away. You have 1 over whatever that thing is times the derivative of whatever that thing is, okay? And these right here, all of these du, dx, all that means is the derivative of the inside. So all of these are just little arrows. Connect all the little arrows here. This is just the derivative of the inside. That's all it means. So this is the sine of something is equal to the cosine of that something times the derivative of that thing. Secant of something, the derivative of that is equal to the secant of that thing times the tangent of that thing times the derivative of whatever that thing is. Okay? The u's just go in there. So you've got to kind of keep this straight. It's not all that difficult once you get your mind wrapped around it, but you got to remember when to leave things alone and when to work on it. Okay? When you rewrite the trig function, the cosine and the secant and whatever, you don't mess with the argument that's on the inside. Right? The trig value is your candy shell, and then the argument that's inside is the tootsie part. So let's look at this right here. We've got y equals cosine of 3x. So dy dx is equal to negative sine times 3x. So the derivative of cosine of something is equal to the negative sine of something times the derivative of that thing, which is what? 3. So your actual answer is negative 3 sine of 3x. Make sense? All right, so then the natural log. Oh, sorry. So we'll have f prime of x here. The natural log of something is equal to 1 over that something times the derivative of that something. What's the derivative of the inside? 10x. So that equals 10x over 5x squared. Can I reduce that? Yep. This x cancels out with one of those. 10 over 5 becomes 2. So my final answer is just 2 over x. You can't read what I wrote, can you? Let me redo that. Can't read it once I started marking it out. That's equal to, so that's 10x over 5x squared. So this x cancels out with one of those. And then that becomes 2. So I'm just left with 2 over x. Okay? We good? Questions? That's why we wrote it like that. The natural log of 5x squared, it's natural log of something. 1 over something times the derivative of that something. So the cosecant, first of all, it's a co, and all the derivatives of the cos are what? Negative. So this is dy dx. I know it's going to be negative. So the derivative of cosecant of something is negative cosecant of that thing times what? Cotangent of what here? Same thing, 7x to the 5th, right? That u gets put in both places. Then I multiply it by the derivative of what's on the inside, and what's that? 35x to the 4th. So my answer then is negative 35x to the 4th cosecant of 7x to the 5th times cotangent of 7x to the 5th. You leave the inside alone. Okay. Any questions on that? Okay. Let's look at g. G prime of x. We know that the derivative of e to the x is just e to the x. So I'm taking the derivative of the e to the 3x cubed thing. So I got to take the derivative of the e part first. Well, it is 5 times e to the 3x cubed. That's the derivative of that e. Then I have to take the derivative of the argument part here, and that's going to give me 9x squared. Everybody understand where everything came from and why? E is easy, but sometimes that makes it confusing, right? Because we didn't change anything. So then this becomes 45x squared e to the 3x to the 3rd power. What questions you got? All right. You want to try I? Try it on your own. See what happens. What's the derivative of tangent? Secant squared. So the derivative of tangent of something is secant squared of that same thing, we don't mess with that, times the derivative of sine, which is cosine of x, and that's it. Understand where that comes from? Yes? So when you look at this and think, we're taking cosine of whatever x is. We're taking secant squared of whatever the sine of x is, because that is the argument for that trig function. Okay? Any questions at this point? Get off your phone or I am taking it. Put it in the box right now. Mm-hmm. Well, they're not on it, so. Yeah, okay. All right. So here we have somewhere we're going to substitute in some numbers. We want to find h prime of 3. They didn't give me h prime of 3. They gave me f's and g's, and they told me what h is in terms of f and g. So I need to find h prime of x first. So remember, we work from the outside in. So f of g of x. So I need to take f prime of whatever g of x is times the derivative of the inside, which is just g prime of x. Then if I want h prime of 3, that means that's f prime of g of 3 times g prime of 3. So then I can start evaluating. This would be f prime of, what's g of 3? 4. F prime of 4. So I did this part. What's g prime of 3? -5. Yes. Am I multiplying the 4 times the -5 here? No. I need to find f prime of 4. What's that? 8. So I'm going to have 8 times -5, and that gives me -40. All right, so this was the chain rule because I had a function inside of another function, right? Is the next one the chain rule? It's the product rule. Very good. So find h prime using your product rule knowledge. Yes. So remember, your product rule is the derivative of the first times the second plus the regular first, like y'all like to say, times the derivative of the second, which that's fine. It's going to help you remember it. And we do h prime of 3. Get -38. Anybody have any questions about any of that? Okay, yeah, that is h prime of 3. Okay, so last one. Is the last one going to be a product rule or a chain rule? Am I going to have to do anything fancy? What should I probably do before I start? Change the x. So I'm going to rewrite k of x before I worry about k prime. That's going to be equal to g of x to the 1/2 power. Product rule, chain rule, or none of the above? Do I have a function inside of another function? Yes, I do. I have a square root function inside my g function, right? So if I have a function in a function, that means I am using chain rule. So to find the derivative, I'm going to do the outside first. So this is going to be g prime of x to the 1/2 power times the derivative of the inside, which is going to be 1/2 times x to the -1/2 power. Does all that make sense? Okay, so I have a variable that has a negative exponent on it, so that means I'm going to end up with a fraction here. What goes in the numerator? G prime. So G prime of, I'm going to rewrite it as the square root of x. It's fine to leave it as x to the 1/2 power, but I know I'm about to evaluate, and I would rather think in terms of square roots. And then in the denominator, I get 2 times the square root of x. Everybody good with that? How did I get to, because I have this 1/2, so the 2 goes in the denominator. This is the square root of x down there. This is what goes in the numerator there. Okay. Good question. Anything else? All right, so now I want k prime of 9. I would highly suggest you actually fill that out, substitute it in. So you get g prime of the square root of 9 over 2 times the square root of 9. So this really is g prime of 3 over 2 times 3. What's g prime of 3? -5, so I get -5 over 6. What questions do you have? All right, so I'm going to give you this worksheet that I want you to work on before I see you next. I'm going to have you circle one that's really part of the set of notes that we're going to do on Monday, which is just more chain rule. We're going to spend a few days on chain rule because there's lots of different things that kind of happen here. But if you look at circle number 14, that's the only one I don't want you even attempting before I see you again. Okay, because we're going to have to talk about something that goes along with that.